Before we go into Lewis dot structures and covalent network solids with covalent compounds, I first just want to go over the properties of covalent compounds. So this is just comparing and contrasting the properties of ionic and covalent. So remember, the big difference between ionic and covalent is how electrons are transferred or shared. So ionic, remember, they're transferred from metal to nonmetal. Remember, with covalent, they're being shared between two nonmetals. Remember, with ionic, we had a crystal lattice. With covalent, we have true molecules. Ionic compounds are typically going to be in a solid state. Covalent, however, can be a liquid or gas. Melting point for ionic are very high. Melting point for covalent are very low. Remember, ionic could conduct electricity when you melted it or dissolved it in water. Covalent typically cannot. Ionic are going to be soluble in water for the most part. Covalent, generally not. And the last property is ionic compounds are going to be brittle. Covalent compounds are going to be the ones you might have an odor associated with because their molecules are very small. They can actually travel through the air as a vapor sometimes, get into your nose, and your nose detects that smell. Okay, before we get into Lewis dot structures then, I want to go over a special type of covalent bonding, which is a covalent network solid. Now, these are considered to be a macromolecule. That means a huge molecule. In these kind of molecules, you have lots of covalent bonds holding the atoms together. These tend to be very hard materials. So remember, I said a covalent usually are not, but in this case they are. These two do not conduct heat or electricity, and they have extremely high melting points, and they're insoluble in pretty much any solvent. So some of these you're going to be familiar with. So covalent network solids, examples of these are going to be diamonds, graphite in your pencil. There's a special type of molecule called Buckminster fullerene. I'll show you a picture of it, and also quartz. So this is graphite. So reason why you can write with pencil lead, which is actually graphite, is because these are actually giant molecules, but they're sheets. They're in the form of sheets. So as you write, like a sheet of graphite comes off your pencil, and that forms the writing you have. Here we have a diamond. All the atoms, the carbon atoms in the diamond are bonded together. That's why it's so strong. And then here is a picture of Buckminster fullerene. This is, sometimes these are called buckyballs. So these actually do form somewhat naturally, like in candle flames. You will get some of these molecules, and they've been explored by scientists to see if they could deliver medication into the body, because the body wouldn't necessarily reject the buckyball, and you can kind of hide something else inside the buckyball and deliver that medication. And the last one here is actually quartz.